Okay, previously we discussed the static of fluid. Then in this case, we discussed the motion of the fluid, that means the dynamics of the fluid. Okay, right. Okay, write down. This is the study of. This is the study of. This is the study of a flow of fluid. A flow of fluid. In order to identify the characteristics of the characteristic of a, the characteristic of a fluid flow. Characteristic of a fluid flow. Okay. Then write down another topic. Fluid flow under pressure difference. Fluid flow under pressure difference. Fluid flow under pressure difference. To flow the fluid, there should be a pressure difference. Fluid flows to which pressure to which pressure, high pressure to low pressure, or low pressure to high pressure to low pressure. So if there is a pressure can be acts as the gravitational or something. There is a pressure. If pressure increase, so is there is a pressure decrease place travel. Okay, right. Then go write down fluid flow under pressure difference. So write down, commonly liquid and gases are considered as commonly liquid and gases are considered as commonly liquid and gases are considered as fluid when there is a pressure difference. When there is a pressure difference, fluid may flow. When there is a pressure difference, fluid may flow. High pressure to fluid may flow. High pressure to low pressure. In extrusion, according to the pressure difference. According to the pressure difference. According to the pressure difference, there is a two type of flow of fluid. There is a two type of flow of fluid. Right. There are two types. First one is streamline flow. Streamline flow. Second one is turbulent. So suppose this one has streamline flow, also called laminar flow. It's a streamline flow, and the second one is turbulent flow, right? If the water travels the high pressure, right, very high pressure to low pressure, that creates the turbulent. It's called uniformly. It is streamline flow. Okay, write down first one streamline flow, second one turbulent flow. Okay. Then write down number one. Let's discuss separately. Number one, streamline flow. Number one, streamline flow. Streamline flow. Write down. Write down. The fluid pass in. The fluid pass in. The fluid pass in. Due to the. Due to the. Due to the small pressure difference. Small pressure difference. Small pressure difference. With small velocity. With small velocity. With small velocity. Called as streamline flow. Called as streamline flow. Called as streamline flow. In a streamline flow, in a streamline flow, the fluid flows as layers, hence also known as laminar flow. I told there is a name for laminar flow. Laminar flow. The path of fluid particle is called streamline. 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 Velocity of same point. Streamline. Then right, velocity of same point are identical in streamline flow. Are identical in streamline flow. This is identical. So I can take it as V3, V2, V1. This is streamline. This is called streamline. Okay. Draw this up. Draw this up quickly. This is called tube of flow. Okay. Write down this. The velocity of the any point can be taken as the value. Draw the tangent to the streamline. Okay. Oh, okay. Write down the tangent drawn. The tangent drawn. The tangent drawn. The tangent drawn at a certain point
on a streamline, indicating the direction of the motion, particle passing through that point, passing through that point, passing through that point, the region through the region through which flow, region through which flow a collection of streamline, a collection of streamline is a tube flow, is a tube flow, tube flow. Okay. Then number two, this is identical. Laminar flow is identical. How can we find the streamline or streamline flow? How we can see the streamline flow in real life? So this flow can be demonstrated using the water line. Using the colors, we can take this streamline flows. So in this example, you can get that part, the mechanics of fluid. So in this case, turbulent mean very high of pressure. So this flow is very not clear. Weak turbulent is not clear. The flow lines cannot be identified, but it's laminar flow. The flow lines can be identified. So you can see there is a, when we uh, place in the colored ink to the water, and this flow is laminar, so we can see there is a flow lines. Flow lines go, they are very identical. See, this flow line is very identical. These flow lines are very identical. We can draw. That's why the type of flow mean, right? They are very identical. We can draw like that. Okay. So see, they are very identical. This is the laminar flow. This is the laminar flow. The flow can very identical. But in turbulent case, we are only discussing this laminar flow. So we are drawing this streamline to every example for the Bernoulli concept also. These streamlines. See, stagnation point we can also do in. It's like a, see. So turbulent mean the sometimes turbulent flow is very, see, this is the laminar flow. This example also, this is laminar flow. This is turbulent, right? This is flow. See, this turbulent flow is used to mix the fruits or mix the chemicals in the industrial applications. So the laminar flow is the flow in everywhere. When we discuss the example, also we discuss only the laminar flow. Okay, write down number two. Number two, turbulent flow. Turbulent flow. Okay. So previously I showed turbulent flow. There is no existing path, right? No existing path, no existing way to travel. They are very and so many complicated ways. Okay, this is turbulent flow. Write down flow passing due to high pressure. Flow passing due to high pressure difference difference is called turbulent flow. Is called turbulent flow. The velocity of a point. The velocity of the point is not identical. Is not identical. They are vary with. They are vary with time, and also there is no identical path. And also there is no identical path. Identical path to flow the particle. Flow particle. Right. This is a kind of turbulent flow. Right. When in the waterfall there is a turbulent flow because the pressures in are very high. Uh, when okay, draw this one. When there is a water canal, when it raining, there is a water canal going in the road. Also, we can see the laminar flow because there is no pressure difference, high pressure difference. This is a laminar flow. Okay, open canal, you can see. Okay, write down. Then we have to discuss the fluids. What are the fluids? Fluids are gases and the commonly take the gases and liquids are fluid. So we have to discuss the fluid. What are the fluids? What are the type of fluid? There are compressible and incompressible fluid. Compressible mean if we gave the pressure, it got compressed. That but incompressible mean if we gave the pressure, that not in compressed. So considering gas and the liquid, when we apply the pressure on the liquid, that is not a sufficient volume change. No, that mean the most of the case the liquids are incompressible. So the compressible mean the compress with the pressure. So most of the case the gases are compressible fluids. Okay, that's why we are discussing it at the heat and also in the chemistry. Air gas laws, gas law. That's why we are discussing that. So write down number one, incompressible fluid. Incompressible fluid. Number one, incompressible fluid. Okay, that means cannot compress. Write down the fluid doesn't change doesn't change. Its volumes with pressure, its volume with pressure is called incompressible fluid, is called the incompressible fluid. The volume of the fluid, the volume of the fluid is constant. The fluid has same density. The fluid has same density in everywhere. The fluid has same density in everywhere. So when we apply the pressure, V does not change. Apply pressure, V does not change. But density equals rho equals M over V. No? If it not change, if it this one not change, the mass is not change, rho is not change. Rho is not change. Okay. That's why I told that one. Okay. Write down this. Volume. Okay. Write down quickly. Then write down compressible fluid. Compressible fluid. Incompressible, compressible, then compressible fluid. What mean by compressible fluid? When we apply the pressure, when we apply the pressure, we get changed with the pressure. So we change, rho equals M over V, we change, rho change. Okay. Write down the fluid which change its volume, the fluid change its volume with pressure, with pressure, they are called, they are called compressible fluid, compressible fluid, compressible fluid. The density may varies, the density may varies, density may varies with the pressure, with the pressure. Okay, right now. Okay, down another topic. Viscosity. What mean by viscosity? Viscosity mean viscosity mean viscosity mean the friction between the fluid layers. Viscosity mean the friction between the fluid layers. If there is a friction between the fluid layers, we cannot apply the Bernoulli principle and other things because there is a friction. So we are discussing this viscosity in the mechanical properties of the metals in near future. So write down the topic viscosity. Due to the relative motion, due to the relative motion of fluid due to the relative motion of the fluid. The layers of fluid, the layers of fluids having a frictional forces, between them, they are known as viscous force. They are known as viscous force. They are known as viscous force. In study of fluid dynamics, the effect due to the viscous force are negligible. Effective due to viscous force are negligible. Okay, write down. Then we go to the parameters. So write down the first parameter. Okay, write down the first parameter. Volume flow rate and mass flow rate. Volume flow rate and mass flow rate. Volume flow rate and mass flow rate. First, we can discuss the volume flow rate and mass flow rate. Write down volume flow rate and mass flow rate. Then write down. Consider a fluid passing through a tube, a tube having a cross section A, with velocity v, right. For this case, we take the like this. So I take the water portion or liquid portion travel with t time, with simple t time. Okay. If we travel with simple t time, I take the length of the liquid portion, liquid body. We know it's traveling with uniform velocity at t time. At t time, I can apply S equals ut. S equals ut mean Vt. X equals to Vt. So this is called Bt. Okay. So if the density of the I take the volume of the liquid. The volume of the liquid body travel at t time. So what is the volume of that one? This cross section is A. A into X. Volume is equal this that one. A X, that means VD. Okay. Draw this one and write down these parameters. Draw this one and write down these parameters. Okay. Okay. Then we can find the volume flow rate and the mass flow rate. Okay. What mean by volume flow rate? Right? Volume per unit time. Write down. Write down. Volume per unit time. Write down. Volume per unit time is called volume flow rate. Is called volume flow rate. WQ. WQ. Q is the volume over time. So the volume equals to what? A V T. We mean velocity. Velocity over T. Time equals T. T to T cancel out. Q equals AV. Q equals AV. This is volume flow rate. Volume discharge. Volume flow rate. Right? Okay. Find out the dimension of Q. Find out the dimension of Q. Find out the dimension of Q. Quickly find out. Give me the answer. Put it in chat. Yes, that is the answer. So this one A into V, that means L square into LT minus 1, L cube T minus 1. So unit is M cube S minus 1. M cube S minus 1. Okay. This is the volume flow rate. Again, I take the mass flow rate. Write down. Write down. Mass of the fluid passing through. Mass of the fluid passing through unit time. Unit time. Unit time is called mass flow rate. Is called mass flow rate. Mass flow rate. Right? That means when write the density of the fluid, if the density of the fluid taken as straw, taken as straws. So mass equal density into volume, no? So density rho, volume equals to what? AVT. So the mass flow rate rho AVT over T. T to T cancel out. Mass flow rate equals rho AV. M dot T equals rho AV. Okay, find out the dimension of M dot and the unit of M dot. Okay, find out. Give me the answer. Give me the answer. What is the unit? Yes, mass over time. Mass over time mean m over t. mt minus 1. This equation also gives that one also. Okay. M dot equals kg s minus 1. Kg s minus 1. Okay, write down. A tube has a problem. A tube has a cross section 20, a cross section 20 cm square, 20 cm square, and having a flow, and having a flow, having a flow 0. Uh, 0.01, 0.01 m cube s1, m cube s1. Find the speed of the fluid. Find the speed of the fluid. Find out v. Find the speed of the fluid. Okay, find the speed of the fluid. It is incompressible fluid, huh? Incompressible fluid. Okay. Find out the Q is Q equals, you know, we have to find V. Q over A. Q mean 0.01 m cube s minus 1. A mean 20, 20 cm. Cm mean 10 to the power minus 2 square. 0.01 20 10 to the power minus 4. It is 0.01 then 100 over 20. 5 ms minus 1. No? Right. Good. The answer is correct. So write down another problem. A tube having a tube having a tube having area 4 cm, tube having area 4 cm square, 4 cm square, and the fluid passing and the fluid passing with 0.5 ms minus 1 velocity, 0.5 ms minus 1 velocity. The density of the water equals, the density of the fluid equals 10 kg ms minus 1, 10 kg m minus 3, 1000, 1000 kg m minus 3. Find the mass flow rate. Find the mass flow rate. Okay, find out. Quickly find out. Yes, what is the answer? So m dot t equals rho a v 1000 rho into 10 to the power minus rho into 0.5. 1000 into 0.5 into 10 to the power minus 5. So this one cancel out minus 1. This 2 into 0.1 to 0.2 kg s minus 1. This is the, yes, this is the mass flow rate.